I hope there is notebook and pen in front of you, and you must have drawn periodic table. So that periodic table should be there in front of you. I have not drawn that periodic table here, but I am having just skeleton. Okay, I should draw somewhat bigger trend here, bigger periodic table here, but I am not drawing perfect. Just to get general idea, I am drawing here periodic table. You're aware 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So these 18 groups are there. Now row number 1, 2, 3, 4, 5, 6, 7. Then from this side, now I am showing a different color. So from this side, lanthanide group, and this side actinide group. Now if you observe this periodic table, I am just draw here only skeleton of periodic table. You are aware now, we are talking of now this horizontal rows. This is first period. In case of first period, there are only two elements, therefore it is called as short period. For example, here the elements are only two, they are hydrogen and helium. Again, check out electronic configuration. In case of hydrogen, the electronic, I am writing here, hydrogen, electronic configuration is 1s1. In case of helium, electronic configuration is 1s2. So which shell? So He is having 1s2 configuration. So both element, say hydrogen and helium, they are having S shell under construction. So they are called as S block element, and that's why people, some scientists, they are saying that this helium should not be here, one should keep helium here, giving you this is second number and He. Now just check out second period. Now I am giving you name here. Okay, this is, I don't want this to happen. I like that helium should be here only another element I can show S block element. Now second period, you are aware there are 8 elements in the period. They are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So 1, 2, 3, 4, 5, 6, 7, 8. So there we are getting 8 elements in the second period. One small mistake was there, just I want to refine this. Here also elements are not there. So next period, that is having sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. So second and third period, they are having 8 elements. So here first period is having only 2 elements. Second period and third period, they are having 8 elements. Now fourth period is having 18 elements. Let us check. It's argon, then potassium, calcium, scandium, titanium, vanadium, chromium, manganese. Many people are confused with magnesium and manganese, beryllium and barium, like that. So this is manganese, iron, cobalt, nickel and neon, confusing element, then copper and zinc. So like that, these elements are there. As I explained that only we have to keep this element in structure. Then potassium, rubidium, cesium, francium. Here fluorine, chlorine, bromine, iodine, argon, krypton, xenon, radon. Now check out. Try any element here. Any one element where you are aware of electronic configuration, you will get that always S shell is under construction. For example, sodium 3s1, magnesium 3s2, potassium 4s1, calcium 4s2. So like that, in this particular block we are getting S shell under construction, and so this block we are calling as S block. So periodic table I am showing now blocks also along with period. Now third period is called as representative element. Why? I don't know. Say scientists are saying we are accepting, because they are saying these elements are representing the element in their group. Yes, say for example sodium. So sodium will give you representation of their entire group. Say seventh period we are not considering. So there are six periods. Out of that, middle one is either third or fourth, and therefore they are considering 3. But I should like the fourth. Why? Because in third period, these 10 elements are not present. But still, they are saying the third period is called as representative element. Alright. Now, this is S block. Now check out any element here except helium. Check out here, boron, 1s, you are aware, atomic number 5, 1s2, 2s2, 2px1, 2py0, 2pz0. Which shell is under construction? P. Fluorine, 2px2, 2py2, 2pz1. Which shell is under construction? P. So like that, check out any element in this particular block, you will get P shell is under construction, and so this block is called as P block element. So this is S block element, this is group of P block. Now check out scandium, atomic number 21, to zinc, atomic number 30. Just check out. You will get 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. 3s2, 3p6, 4s2. Calcium, 4s2 onwards, we have to move from scandium, 3d1, 3d2, 3d3, 3d4, 3d5, like that till Zn 3d10. So which shell is under construction here? D. So check out any element in this particular part, you will get D shell is under construction, and so these elements are called as D block element. So we can keep this way: S block, P block, D block. Now here, this is the lanthanum. Lanthanum onwards, the elements are there, but we are not discussing these elements right now. They are called as lanthanide, and these elements are called as actinide, where F shell is under construction. We are not discussing these elements in detail right now, because I want to take separate chapter, that is lanthanides and actinides. It is bit difficult. For that purpose, various concepts and particularly coordination compounds we have to discuss. Then only we can get, then radioactivity chapter is there, that I have to discuss then. And so right now I am not going to discuss this, but you can check out any element here. We will get these elements, they are having shell under construction, that is F shell, and so these elements are called as F block element. I I hope you must have carried out electronic configuration of uranium. Try to recollect, in our earlier atomic structure chapter, we discussed this uranium, atomic number 92. The last shell configuration was 4F4. So like that, elements 5F4. So elements, they are under construction, F shell is under construction, and so we are getting F block elements. So like that, periodic table is divided here. Now in case of here, the periodic properties are same. Say for example, you can get regular gradation in atomic size, that atomic size decreases, only argon is exceptional. Then IP value increases, yes, but exceptional magnesium and phosphorus, they are showing exceptional high peak, and ultimately argon, no doubt, it is going to show exceptionally high peak. But scandium onwards, the decrease in atomic size decreases. What word I am using? Decrease in atomic size decreases. That means for these 8 elements, we are getting considerable decrease. But for this 10 element, decrease is not that. No doubt, the atomic size is decreasing out, but not as per expectation. And therefore, these elements are showing somewhat similar characteristic. Say, I am using word here, somewhat similar characteristic, because 4s2 shell, that is outermost shell, remain constant. Electrons are added in 3D shell. We are calling that as second last shell, or rather in high class language what they are using, we are calling as penultimate shell. Ultimate is last, penultimate is second last. So electrons are added in second last shell. This is the characteristic of these all element, that is from scandium to zinc. So like that, if you order here, observe here, what in earlier periodic table we are calling this group as B. So it was B capital, say 1A, 2A, Roman 1A, 2A, then 3B, 4B, 5B, like that. These elements are having somewhat similar characteristic. These all elements are showing metallic characters. They are showing colored compounds. Zinc is not showing exceptionally, but they are showing, zinc is exceptional. Every time I should not say. These elements are showing colored compound. Then coordinate compounds are also formed nicely by them. These elements are showing metallic characters. They have very high melting and boiling point. They are showing very high malleability. All these metallic characters are shown by these elements. Their atomic sizes are considerably low, and therefore their crystal structure is perfect, having comparatively less void. Void means empty spaces. So these all characteristics are possessed by these elements. They are called as they are called as transition element. Okay, let us check out these concepts also, because they are their part of our chapter. Last group, that group 18, and in earlier day it was called as 0 group or group 8b. These elements are having 0 valency. You are aware of valency, that is number of electrons either donated or accepted to complete octet, or shared also to complete octet. So here their octet is already completed. Octet means either 2 electrons in, that is duplet actually for helium, and neon onwards 8 electron in last shell. So they required 0 electron to donate, share or accept, and therefore these elements are not showing any compound. So their valency is 0. No doubt scientists made them to form compound. So xenon is giving very good compounds with fluorine and oxygen also later on. But this is not right now part of our topic. So these elements are called as inert element, noble gases, because their all shells are completely filled. Now in case of this element, that is S block and P block, you will check only last shell is incompletely filled. Till that all shells are completely filled. Only last shell is not completely filled. So we are calling them as normal elements. So first category, noble gases, 8 group. Second category, normal elements, that is S block and P block. Third category we are calling transition element. Just we have checked here that 4s2 that was there, that is last shell, but then onwards electrons are added in second last shell, that is 3d, and so this is called as transition element. Now in case of this element, electrons we have checked in fluorine, in case of electronic configuration of uranium, that shell under construction is F. So 5F shell was under construction, but 6th shell is incompletely filled, 7th is incompletely filled. That means last 3 shells are incompletely filled. We are calling this category of element as inner transition element. So 0 group or group number 18, inert gases, noble gases. S block and P block, except this, we are calling them as normal element. D block or here the element named as B, or here D block element, we are calling last 2 shells are incompletely filled, transition element. Last 3 shells are incompletely filled, inner transition elements. Now we are coming to these 2 periods where they are considerably long period. They are having 18 electrons, 18 element each. Then it is 6th period which is the long period. Why? Because 14 elements of lanthanide, they are here. Actually I am showing here, but practically speaking they have placed like this, perpendicular to the board on this part. So they are called as 14 element additional. So 18 element plus this 14 element. So 32 elements are there in this group. So this is long period, that is 6. And 7th period is also long period. In old days when we used to study, at that time this period was incomplete because elements were not discovered beyond 105. When I used to study, there were 105 elements, but now number is increased and newer isotopes as well as newer elements are also produced over here. So this period in earlier days was called as incomplete period, but now it is almost going to complete. I don't know, because this present day whatever going on, that knowledge is not with me. So in our days when we used to study, we were calling this as incomplete period, but now it is almost going to completion. But still I don't know whether elements are studied out to 100% because they are having very short half-life period. In nuclear chemistry we will discuss this, but right now we can consider that the element is formed, immediately it is exhausting out. So I can't study out chemical properties at detail level over there, and that's why we are usually not considering 7th period in our calculation, or whatever the periodic properties are there, we are not studying out for the 7th period. But radioactive elements are part of 7th period. Alright, so now you got idea according to period. Now we have to discuss according to the groups. The first group we are calling, only 3 groups I want to discuss. The first group we are calling as alkali metal. Except hydrogen, all these elements are in metallic state. They are called as alkali metals as they are forming very good alkali, sodium hydroxide, potassium hydroxide. Second group we are calling as alkaline earth metals, because they are obtained from earth, like calcium, then magnesium, etc. They are called as alkaline earth metal because their nature is also alkaline. Third important group we are calling here, that is 17th number group or 7th A group, that is called as halogen. Halos means sea salt. So obtained from sea salt, therefore we are calling them as halogen. And last, obviously you are aware, 0 group, that is group of inert gases. Alright, so this is giving you about very general idea of periodic table. We have not discussed this chapter in detail, but various concepts, those are essential for our discussion, we discussed out in brief.